Hey guys, welcome back to the channel. Tonight we're taking a look at the Detrum Z3 Autopilot. As you know, over the last several weeks I've done quite a bit of product review from BitGo Hobby, and tonight we're taking a look at the Detrum Z3 Autopilot, also sent by BitGo Hobby for review. And I just want to encourage you, if you're in the market for an autopilot or a stabilizer or one of those nice Tomcat motors or any of the Dyna warplanes that we've been reviewing, or even civilian planes like the Grand Cruiser and the Waco, make sure to check out BitGo Hobby. They've been a very good partner to the channel, and they're putting a lot of resource into RC video reviews so you guys can get first looks at equipment like this in the airplanes, and you can see the testing and how this equipment performs before you shell out your money. So if any of the material I've put together has helped you make up your mind on making a purchase, it's only fair to give BitGo Hobby a look before you spend your money. Okay, with that said, I want to talk a little bit about what's so special about this Z3, and at the end, after I kind of cover the autopilot itself, I want to give you a little bit of a so what, why is this important to me? Let me start off by saying first that if you watch the SR86AG video where I put that autopilot in my Millennium Master and flew that around, the important thing to understand about that system is that is a self-contained receiver and autopilot all in one, and it's designed to go with a radio like the Detrum Blitz DT9 or the Gavin 8C or 6C or one of those. So that's a self-contained radio and autopilot. The Z3 is just an autopilot, meaning there is no receiver built into it. It's just an autopilot function. So when you buy a Z3 Autopilot, you'll get the autopilot unit itself, the GPS puck, and a couple of accessories to help mount the unit in your airplane, like the servo extensions and even some 3M mounting tape, and of course some instructions. Again, it's not a receiver. That's what this little guy is for. This is a FrSky XSR S.BUS receiver. It's very small. I'll try to give you something to that'll help you understand just how small this thing is. Here we go. There's a little, everyone knows what these are. This is a little bottle of Tester's paint, and that's it. That's how small it is. It's as tall as a bottle of paint. So very small little unit, and it's only capable of doing S.BUS. There are no, you notice there are no pins on this one. There's no header pins that let you connect an analog servo to this. So it connects to something like a Z3 via S.BUS. The Z3 supports for input S.BUS and CPPM. CPPM is it's an older protocol. It's a multi-channel protocol. It's analog. S.BUS is digital. For most, if you have the option, S.BUS is the preferred option. But I want to show you first just how easy it is to set this thing up, because it is brain dead simple. Okay, so to show you how this all works, I connected my BEC to the PPM input on the Z3, and that just provides power. So what that tells me is that the positive rail on this is all common throughout the whole device, because when I plug that into the PPM output or input, the receiver lit up and the servo also works. So it is definitely a common power rail on that. My receiver now, the XSR, and when you get these types of receivers, you're probably going to have to do a little soldering. I had to solder a standard servo connection onto the signal and power wires for this receiver. Follow the instructions that come with your receiver to figure that out. And then I plugged that into the S.BUS on the Z3 right here. So that's it. My receiver is plugged in to the S.BUS port, and my power, my BEC, BEC, is connected to the PPM port, and then after that it's just a matter of connecting the servos. So the radio configuration, real simple, just like any other. Let's see if I can get a good look at this. So just like any other radio configuration, I'm using aileron, elevator, throttle, rudder, and you'll notice on channel 5 right there I have a switch SC for the mode, and that's it. On the Taranis, it's that simple. You don't need to do any other configuration other than that. Just put a switch on channel 5 and it works. Okay, so here's what it looks like when you plug it in. I'm connecting the battery now. Here's my BEC. I'm just going to connect it. To unlock it, I'm just going to move my throttle down to 0 and pull my rudder all the way in, and you'll watch that red turn from red to green. You see that? Now it's active. And now I can activate just by moving my mode switch, which I had set up on SC, which is this switch right here. Right now it's stabilizer off. When I put it in the middle position, the stabilizer is on, and then when I put it in the bottom position, it's in safe mode. That's it. It's that simple. And you can see that with the stabilizer off, when it's green like that, when I move the stabilizer around, the servo's not doing anything. See? Servo's not doing anything. Now when I put it in the middle mode, the stabilizer's on, that's wind rejection. So when I first move the unit, you'll see the servo make a correction and then go back to neutral. That's wind rejection mode. And then when I put it in safe mode all the way down, that's the teal color. When you turn the stabilizer on its axis, it'll hold that position on the servo until the stabilizer is returned back to neutral. So that's safe mode. So that's it. It's got to be one of the easiest stabilizer configurations ever. All right, so let's wrap up the initial discussion on the Z3. So the important piece of this is that you can use this autopilot on any S.BUS receiver. It does not have to be Detrum. It can be any receiver that works with your radio. You simply connect your S.BUS receiver to the S.BUS port on the autopilot, and then you connect your analog servos or your digital servos to the output rail on the flight computer. When it comes to programming a device like this, the industry has had several different approaches. They've got USB dongles and programming cables and Lewis scripts and over-the-air. There's all kinds of different approaches to doing this. One of the things that I really like in Detrum's strategy is the simplification you get with using something like a 3-in-1 programming card. So you take a device like this, plug it into the Z3. Now keep in mind, this only works on Detrum equipment. You can't just plug one of these 3-in-1 programming cards into any old computer you have. It's got to be something that's made by Detrum. This is a device by Detrum for Detrum equipment. And then once you've done that, it's as simple as going into this menu-driven interface and choosing your configuration options. So if I want to go down and say, well, the mounting direction on this unit is down, I just simply select that option and then hit down. And that will program the device to allow me to mount the unit on its backside like that. If I want to use a delta wing configuration, same thing. I just go in here and select delta wing, change it from normal to delta, and that's it. The computer now does the mixing for me. So you might say, well, John, what's the big deal? Because this in and of itself is not earth-shattering, but here's why it's a big deal. Let me just show you why I think it matters. This is the so what moment, okay? And this is what I like about what Detrum's doing with their product lineup. This is a Turnigy Aerostar, and to configure this one, I've got all these little dip switches right there, and I couldn't tell you what those mean, which means I'm going to have to go dig up a manual, hopefully online, because I'm sure I don't have the manual anymore, and I have to figure out what those dip switches mean. And then I'm pretty sure that those pots right there are for setting the gains and the direction on the outputs. So that's one device, one technique. For programming ESCs, that's one for a Hobbywing ESC. That's one for a Turnigy ESC. This is for a ZTW ESC. If you're using the 3-in-1 programming card, you've got an option right there on the side for your ESC. So this will take care of all your ESCs as well. So now we've eliminated these three and this guy. Now, if you're using something like a Hobby Eagle Super 2, which I love these. This is my first exposure to a real top shelf stabilizer in a plane. But you can see in this box, I've saved this very proprietary cable. You're not just going to pull something out of your USB kit and expect that to work. That's a proprietary link. So you have to save that. And that's how you program the Super 3. And I have no idea what kind of software driver. I don't remember what kind of software driver. So I'll have to go do research to figure out what kind of software driver I need to install on my computer so I can connect that USB and then connect to the A3 Super 3. I don't know. If you want to do an FrSky S6R, you have to have this S-Port Tool STK programming device, which, by the way, doesn't always work. I've had some issues getting this to work. Or alternatively, you can download a Lewis script and run the Lewis script on directly from your radio to configure the S6R. The point of all this is that Detrum's on the right track by using a very simple programming device like this 3-in-1 programming card that lets you connect it to things like a standalone autopilot or a standalone iStone stabilizer, which I've already done a review on, and your ESCs and the integrated receiver and stabilizer options like the SR86AG. The idea then is that you get rid of all this other stuff. And by the way, just to do this video, I had to go hunt all this stuff down. I knew I had it, but I had to go hunt it down. I had to go dig through different boxes and different places and where I store that kind of stuff, and I had to go hunt that stuff down. That's just to do an example, and that's just a small stack. That all gets replaced with one of these. That's the so what moment, and that's what I like about what's going on here. Not to mention the fact they're price competitive. So I've already done the SR86AG review, and I've demonstrated that that return to home function works very well. And I'm sure that it's the same software inside this Z3 that's in the SR86A. I'm sure it is, because the 3-in-1 card reads it as the iStone stabilizer. So I'm confident that this configuration will work just the same as what we saw on that Millennium Master demo that I did. Now let's close out the video by talking about why you might need this, because I opened it up and I said, you know, we fly our planes today without stabilizers and return to home, and they do just fine, and for most cases it's probably true. So why would you want something like this? Well, one of the things I can think about is, let's say for example you want to get into FPV. So if you want to learn how to fly FPV, having a return to home function is really important, because with FPV, if you're under goggles, even if you have a spotter and you're following the letter of the law and you have a spotter, if something goes wrong and you have to come off goggles, you may not instantly know or be able to acquire where your plane is or what it's doing. Even if you have a spotter going, it's right there, it's right there. So having the ability to flip a return to home switch is an immense safety blanket if you're learning to fly FPV. That's case number one. Case number two, if you're learning how to fly on your own and you don't have any help at all, these things can save your bacon. Now, I would say if you're a rookie, you really have to spend the time making sure it's configured correctly and set up correctly. But once you've done that and you've tested it, then you get a little bit of a safety blanket that says if you're out flying and you get disoriented or confused about something, you simply hit your return to home switch and the plane will level itself, come home and circle. And by the way, while it's circling, you can calm down. Your thumbs will stop shaking and you'll stop freaking out. And then when you're ready to resume controlling the plane, you could take it off, return to home, and fly it the rest of the way home. Or do whatever it is you want to do to complete your flight. So that's a use case number two. Use case number three, let's say for example you have a very expensive plane. Let's say you spring for the rimfire motor and the 100 amp BSC, and you might even put a pitot tube on it to see how fast it goes, and you've put some money into this airplane. One of these flight computers might be just the ticket to help you preserve the plane if something goes wrong. You lose orientation, or something doesn't feel right about the plane and you get nervous, or whatever, whatever. The sun blinds you. You can hit return to home and have your plane circle overhead while you regain your bearings and take control of the plane again. So that's use case number three. Those would be the scenarios where I'd say having a return to home function is actually very nice. There are other outlier opportunities too, like using it for a camera platform. You can put a recording device on a plane, put it in return to home, and just have it circle for a while. That can be kind of fun. You could use it for chasing. I know I've talked to some guys who put an airplane in return to home and they use their drone and chase the airplane around to develop airplane chasing skills with the drone. So there are other outlier benefits too, but I would suggest the ones I covered are ones that would be mainstream, what I would consider mainstream uses for the average RC hobbyist. So there you go, guys. There's the first look at the Z3 Autopilot by Detrum. Thanks to Bitco Hobby for sending this unit out for review. I will be putting this in an airplane and taking it out to the field and testing it to show you guys how it works, and look forward to that video when I get to it. Other than that, that's all I've got for tonight. I hope you have a great night. Take it easy. Now, in order to remove the lock, I'm just going to pull my rudder switch and my throttle, to unlock. There are some outliers too, like there are opportunities. Always a text while I'm filming.